The National Electrical Code, or NEC, addresses grounding and bonding requirements for electrical systems. Article 250 within the NEC is dedicated to grounding and bonding. Section 250.110, titled Equipment Grounding Conductor Connection to Grounding Electrode System, states that equipment grounding conductors must be connected to the grounding electrode system as specified in Article 250, Part Roman 4. Section 250.112, titled Connection to Electrodes, further clarifies that the grounding electrode conductor should be connected to the grounding electrode system at the service equipment, following the guidelines in 250.112 Article 250, Part Roman 4, specifically addresses the grounding electrode system. Section 250.568, titled Grounding Electrode System, outlines the permissible components of this system. These include firstly, rod, pipe, or plate electrodes, secondly, concrete encased electrodes, thirdly, ground rings, and fourthly, other listed electrodes. Section 250.144, which falls under Article 250, Part Roman 8, Grounding Conductors and Connections, addresses grounding electrodes for lightning protection systems. It clearly states that grounding electrodes used for lightning protection systems should not be used as a substitute for the grounding electrodes required by the NEC. Section 250.148a, also within Article 250, Part Roman 8, focuses on grounding conductors equipment. It states that grounding conductors for electrical equipment should be insulated, covered, or bare, and must be protected from physical damage. Concerns sometimes arise regarding corporate safety mandates that call for separate grounding for electrostatic discharge, or ESD, versus electrical equipment grounding. These mandates may stem from concerns about potential differences between these two systems. It's important to note that the NEC does not explicitly mandate separate grounding systems for ESD. A critical safety concern arises when the ESD grounding system is separated from the electrical equipment grounding system. This separation can create potential differences between the two systems. If an ESD workstation and electrical equipment are not at the same potential, the risk of electrical shock or ESD damage can increase significantly. To ensure workplace safety and minimize ESD risks, several recommendations should be followed. Firstly, compliance with the NEC code requirements for grounding and bonding is essential. Secondly, consultation with qualified electrical engineers and safety professionals is necessary to assess potential differences between the ESD and electrical equipment grounding systems. Thirdly, implementation of appropriate measures is needed to ensure that the ESD workstation and electrical equipment are at the same potential, which can be achieved through bonding between the two systems. Fourthly, adherence to the recommendations of ESD industry standards is crucial, as these standards typically advise against separate grounding systems for ESD. Let's delve deeper into the NEC requirements. Grounding and bonding are fundamental concepts in electrical safety. Grounding provides a path for fault current to return to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to operate and clear the fault. Bonding ensures that all metallic parts of an electrical system are at the same potential, minimizing the risk of electric shock. Article 250 of the NEC provides comprehensive requirements for grounding and bonding, covering everything from the grounding electrode system to the sizing of grounding conductors. The grounding electrode system is the foundation of the grounding system. It provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provides a low impedance path for fault current. As previously mentioned, the NEC specifies several types of grounding electrodes, including rod, pipe, and plate electrodes, concrete encased electrodes, and ground rings. The choice of grounding electrode depends on soil conditions and local requirements. The grounding electrode conductor connects the grounding electrode to the service equipment. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Equipment grounding conductors provide a path for fault current from electrical equipment back to the service equipment. These conductors can be wires, metal raceways, or other approved means. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. Bonding jumpers are used to connect different metallic parts of the electrical system together, ensuring that they are at the same potential. Bonding jumpers are required at service equipment, enclosures, and other locations where metallic parts are likely to become energized. Now, let's address the specific concerns regarding separate grounding systems for ESD. ESD is the sudden flow of electricity between two electrically charged objects caused by contact, an electrical short, or dielectric breakdown. ESD can damage sensitive electronic components, leading to equipment failure. ESD control measures are essential in environments where sensitive electronic components are handled, such as manufacturing facilities and laboratories. These measures typically include grounding workstations, wearing wrist straps, and using static dissipative materials. The concern with separate grounding systems for ESD arises from the potential for creating a difference in potential between the ESD grounding system and the electrical equipment grounding system. If a person or object comes into contact with both systems simultaneously, they could experience an electric shock. Additionally, a potential difference between the two systems could lead to ESD events damaging sensitive electronic components. ESD industry standards typically recommend against separate grounding systems for ESD. Instead, they advocate for a single-point grounding system where all grounding conductors are connected to a common grounding point. This helps to ensure that all parts of the electrical system are at the same potential, minimizing the risk of electric shock and ESD damage. In situations where corporate safety mandates require separate grounding for ESD, it is crucial to consult with qualified electrical engineers and safety professionals to assess the potential risks and develop appropriate mitigation measures. These measures may include bonding the ESD grounding system to the electrical equipment grounding system, implementing equipotential bonding planes, and providing training to employees on ESD control procedures. Equipotential bonding planes are conductive surfaces that are connected to the grounding system. They help to equalize the potential across a large area, reducing the risk of electric shock and ESD damage. Training employees on ESD control procedures is essential to ensure that they understand the risks of ESD and how to properly handle sensitive electronic components. This training should cover topics such as grounding workstations, wearing wrist straps, and using static dissipative materials. In summary, the NEC provides comprehensive requirements for grounding and bonding electrical systems. While the NEC does not explicitly require separate grounding systems for ESD, it is important to address the potential risks associated with such systems. Consulting with qualified electrical engineers and safety professionals is crucial to ensure that the ESD workstation and electrical equipment are at the same potential, minimizing the risk of electric shock and ESD damage. Adhering to ESD industry standards and implementing appropriate ESD control measures are also essential for protecting sensitive electronic components. The NEC provides a framework for safe electrical installations. Grounding and bonding are critical aspects of this framework. By following the NEC requirements and best practices, you can ensure the safety of people and equipment. The NEC is updated every 3 years, so it is important to stay current with the latest edition. Changes to the NEC can impact grounding and bonding requirements, so it is essential to be aware of these changes. Understanding the principles of grounding and bonding is essential for anyone working with electrical systems. This knowledge can help you to identify potential hazards and take steps to prevent accidents. Grounding and bonding are not just about complying with the NEC. They are about protecting people and property from the hazards of electricity. By taking the time to understand these concepts and implement them properly, you can create a safer electrical environment. Always consult with a qualified electrical professional for any electrical work. Electrical work can be dangerous, and it is important to have the work done by someone who is trained and experienced. An experienced electrician can ensure that your electrical system is properly grounded and bonded, and that it meets all applicable codes and standards. Grounding and bonding are essential components of a safe electrical system. By understanding the NEC requirements and best practices, you can help to prevent electric shock and other electrical hazards. Always prioritize safety when working with electricity. Remember to always disconnect power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of your surroundings and avoid contact with energized parts. If you are not comfortable working with electricity, call a qualified electrician. Safety should always be your top priority. Taking shortcuts or ignoring safety precautions can have serious consequences. Always follow the NEC requirements and best practices, and consult with a qualified electrical professional when needed. A safe electrical system is a reliable electrical system. By properly grounding and bonding your electrical system, you can help to prevent equipment failure and downtime. A well-maintained electrical system will provide years of reliable service. Regular inspections and maintenance can help to identify potential problems before they become major issues. Don't neglect your electrical system. Take the time to inspect it regularly and address any problems promptly. This will help to ensure the safety and reliability of your electrical system for years to come. Understanding the NEC requirements for grounding and bonding is essential for anyone involved in electrical work. Whether you are an electrician, engineer, or building owner, you need to be familiar with these requirements. The NEC is a complex document, but it is essential for ensuring the safety of electrical installations. Take the time to study the NEC and understand its requirements. This will help you to make informed decisions about your electrical system and ensure that it is properly grounded and bonded. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional for any electrical work. Electrical work can be dangerous, and it is important to have the work done by someone who is trained and experienced. An experienced electrician can ensure that your electrical system is properly grounded and bonded, and that it meets all applicable codes and standards. Remember, safety is always the top priority when working with electricity. Take the time to understand the risks and follow the necessary precautions. By doing so, you can help to prevent accidents and create a safer electrical environment.